Okay, so here we are with the continuous distributions, right? So what happens here is exactly what we had done previously in the discrete random variable, but in the continuous random variable, we can draw some plots, right, and graphs, right? So just imagine that this is the probability distribution. We shall be having two axes. This is the vertical axis, the dotted line. There's another dotted line on the top right corner. I'm drawing a small graph, right? Small plot over there. So the x-axis, the horizontal axis, the x-axis will be denoting the random variable values, right? And the y-axis is fx. What is fx? Fx is the density, density, right? The probability density. So in order to find out the probability value, what we need to do is basically use integration over here, right? So we'll have to shade this area and we'll find out the area, this region, area of this region. We'll shade this region and we'll find out the area of this region, and that will give us the probability. Okay, so the probability is this area over here. I'll denote it by P. So probability is the area of the region, and in when we deal with continuous random variable, we never talk about probability of a single value of the random variable. We always talk about the range of random variable values and the probability between those two values. Okay, having given this introduction and the continuous random variable, let's get into the more detailed and nuanced uh, part of the topic. Okay, so yeah, uh, so this is called the exponential distribution. So the exponential distribution, what so let's write down the density function. So f of x, right? We are not writing p of x over here. So what is f of x? This is the density function, density function. This is the y-axis value, density function. So the density function is going to be lambda multiplied by e to the power of negative lambda x. Okay, so this is quite similar to, so see there is a lambda part here, there is a lambda over here. Hmm? This lambda is basically the distribution rate. Oh, by the way, before that I must mention that the value of x should be greater than 0. Okay, so when x is less than 0, there is no value whatsoever. So exponential distribution is relevant only for positive random variables, right? So point number one, valid valid only for positive positive random variables. When x is less than 0, we cannot use exponential distribution, and that's where the next distribution called the normal distribution will come. That density function is a little bit more uh, like accommodating to negative random variable values. Okay, so this is so in this formula we can see something called the lambda, right? So the lambda is called the distribution rate. Okay, so this is called the distribution rate. And well, before getting into the example, let me write down the mean, right? So the mean mu is the reciprocal of the distribution rate 1 by lambda. So you remember in the Poisson distribution, the lambda, the average was equal to the mean. But here, in case of exponential distribution, the distribution rate is lambda, but the mean is 1 upon lambda. And the variance here, the variance sigma square is equal to 1 upon lambda square. Okay, so this is the variance, this is the mean, and uh, that is lambda multiply e power minus lambda x is called the um, it's called the density function, the probability density function of the exponential distribution. And it's imperative for us to know how the graph looks like. So I'm just drawing a graph of how the probability distribution looks like. So we are looking just at the positive direction of x. This is 0. The vertical axis is f of x, right? Okay. So we are just looking at the right side of the vertical axis, and the graph would look something like this. Okay, the graph will look something like this. As the value of x increases, the graph will come closer to the x-axis, right? And if you look at, oops, if you look at this area in between, below the graph and above the x-axis, this area will be equal to 1, right? We have seen, right, in previous classes as well, that the probability is always, the sum of the probability is always equal to 1. Okay, now so this is a very widely used probability distribution. We'll try to write down a few uses of the probability of this probability distribution, right? So one of the most common examples is, let's say, there is a radioactive material. So this material has a half life. Okay, it has got a half life. So what is a half life? Half life means that after a certain period of time, after this period of time period of time, the quantity becomes half. Quantity becomes half. So just imagine that the half life of the tiffin, of the lunch that you bring to the college, is 5 minutes. So in the first 5 minutes, you will eat half of your lunch. So your half of the lunch is left for you. Now in the next 5 minutes, you will eat half of what is left. So after eating half of what is left, 1/4 will be left, right? So I'll just try to draw a small picture here, right? So this, let's say this is your tiffin or the radioactive material. So after the first 5 minutes, you have already eaten this. So what is left is the right hand side. Then after the next 5 minutes, you have only, what is left is this part, the shaded region, right? And then again, after the next 5 minutes, you are left with this shaded region, right? And again, after the next 5 minutes, you are left with this shaded region. So after 20 minutes, what is left is this small part on the right, bottom right corner after 20 minutes. So this is left after 4 half-lives, right? So in order to calculate how much of food is left, or how much of the radioactive material is left after 23 half-lives or 529 half-lives, we use the exponential distribution. And if you notice this carefully, the material does not end, it doesn't go to zero, right? It is always getting half, and there is a non-zero amount left. You are not subtracting, you are just dividing it, right? So it is never going to get to zero. Of course, when once you approach infinity, the amount is tending to become zero. It will become like really, really less, but there will still be something left. So, so in radioactivity, like Madame Curie and Perry Curie, they had got the Nobel Prize for using and describing this particular distribution. Okay. And one more example that can be used, that I can give you on the top of my head is, like, so on the DNA, so the DNA strand looks like this, right? That's the DNA. So on the DNA, there are, I'm sure some of you are quite interested in biology. So in the DNA, let's say that there are some mutations, right? So let's say there is a mutation here, there is a mutation here, right? And as researchers, we are interested in finding out what is the distance between these two mutations, right? So in order to find that out, we can also use exponential distribution to find distance between. So we can, maybe if you're interested in knowing how to do this, maybe we can meet uh, offline and we can do it. We can have a small research paper reading session, mutations between mutations on the DNA, right? On the DNA strand. Okay, now let's get to some example, right? And try to understand, just to recall what the formula was. The density function is given by lambda times e power minus lambda x for x is greater than 0. Again, the value of x has to be greater than 0. It has to be positive, right? Uh, so in, we need to find out from the question what is the value of x, what is the value of lambda. Lambda is a distribution rate, and we can go ahead with our solution. The mean is given by 1 upon lambda, and the variance is given by 1 upon lambda square. So in the question, it might be possible that the value of lambda is given or the value of 1 by lambda is given. Either the distribution rate will be given or the mean will be given. So finding out whether the mean is given or the distribution rate is given is of prime importance. Okay, so let's try to solve a problem. I have a problem here. It's kind of similar to the problem that we had solved a little while back. Okay, so this is again the call center. So a call center receives, CEIVES, receives two calls, two calls per hour. Okay, again the same type of the same story, but here the question will be different, and hence the distribution that we are going to use is going to be different, right? The question is, calculate the probability, calculate the probability, or find the probability that that a phone call, will come in next 1 hour. See, what is the difference in the question? Here we are trying to find out the probability that a call will come in the next 1 hour, right? Uh, so in the but in the previous question, the question was find the probability of zero calls. It doesn't mention whether it is there in the next minute or next hour or whatever it is. We are just concerned about the probability of how many calls, right? It could be 5 calls, but the time duration is not mentioned, whether it should be in the next 1 minute or next 5 hours. Whenever it comes, we so if it is not mentioned at what time the call should come, we are going to use the Poisson distribution. However, if it is mentioned in the question, uh, find out the probability that a phone call will come in the next 1 hour, right? If it is clearly said, then we are going to use the exponential distribution. Okay, so what I'll do is that maybe I'll increase the line over here. Okay, cool. So from this question, you can find out the variables that we require, right? So first of all, 2 calls per hour. So this is the average. This is the average, or this is the expected value. We are expecting that we are going to get 2 calls per hour, and the next 1 hour. So the duration is mentioned right here. So this will be our value of x. right? The success, so-called. Here we are not having the concept of success, but still, next 1 hour. Okay, now let's try to solve this problem, right? So in order to solve this problem, we will look into let's look into the variables. So lambda, no, not lambda, mu. So mu is the mean, right? Mean is 1 by lambda, which is equal to 2, and x is equal to 1. Correct? Okay. Now, uh, okay. Now, what we'll do is that we will see how we can do it. So, um, so next 1 hour. So 1 by lambda is equal to 2. 1 by lambda is equal to 2. We need to find out the value of lambda. So lambda 2 lambda will be equal to 1. We are cross multiplying this, and lambda will be equal to 1 by 2, right? That is 0.5, right? Okay, cool. Now, so what we do next is we will try to put the formula and find out what it is. So the probability of call in next 1 hour will be equal to lambda e to the power minus lambda x, right? So that was the formula. That was the formula, right? So the formula as is given here, you can see in the top row, the density function formula is given by uh, fx equals lambda multiplied by e to the power of negative lambda x, right? So we have the value of lambda as 0.5, we have the value of lambda as 0.5, and x as equal to 1. So let's substitute those values. So lambda is 0.5 multiplied by e raised to the power minus 0.5 multiplied by 1. So it's 0.5 multiplied by e raised to the power minus 0.5 again. So I am going to use Google to find out this value. Google calculator is a very reliable calculator. And okay, so I think that part of my screen is not shown to you, minus 0.5, but I'm going to share how it looks like. Mm, take a small screenshot, right? Okay, okay. This is how it looks like. Hmm? I have typed e raised to the power 0 minus 0.5, right, on the screen. You can see it, right? So I have typed this one on Google, and Google has given me the answer. So basically, if you have this exp, you type exp, that is the first button you have to type, and then you type the negative symbol, minus symbol over here, that is the second one. Then you type 0, third button to press, point, the fourth button to press, 5, the fifth button to press, and equal to symbol, the sixth button to press. In this sequence, if you press the buttons, you are going to get the answer as 0.6065, right? So therefore, probability of getting a call in next 1 hour is 0.6065. Also, if you are not that so if you are little uh, curious about the value of e, right, that we have used over here, right? The value of e will be uh, the value of e, you can directly maybe put the value of e here. I'll use this pen over here. E is equal to 2.718 8. Dot, dot, dot. So E is a very important number, by the way. We're going to use this value of E many times. But thankfully, our computers, they know about the value of E. Okay, so this is how we solve this problem. Hmm? Okay, let's okay, so what we'll do, uh, we'll okay, so by the way, uh, since we have got the value of E, value of the probability here, we can also find the value of mean and the variance, to be very specific. So the mean is already given in the question. The mean mu is 1 by lambda, that is 2, right? Lambda is 0.5, so 1 divided by 0.5 is 2, that is already given. And the variance mu, not mu, sorry, lambda square, sorry, sigma square is 1 by lambda square, that is 1 divided by 0.5 whole square. Now 0.5 whole square is 0.25, and 1 divided by 0.25 is 4. So the mean and variance is also, we have obtained the mean and variance of the problem. Okay, so what we did from the beginning is we have identified the probability distribution, probability density function of the exponential distribution, that is lambda times e to the power minus lambda x. And this is true only for x which is greater than 0. For negative value of x, we do not have this particular formula. Okay, so here lambda is the distribution rate, and the mean and variance are given as you can see on the towards the bottom of the screen. You can see that mean is 1 by lambda and the variance is 1 by lambda square. And then we solved the problem. Cool. Okay, so are there any doubts over here? Of course, we have just solved one problem. We will be solving some more problems in the class maybe, or I'll give you some homework. Any doubts from anyone? No? Yes?
No, sir.
Okay. Okay, so now let's move on to the last distribution, and that would be it for today. So we will be studying the normal distribution, NORMAL, normal distribution. And this distribution is used far and wide, many, many places, right? This distribution is also known as the it's also known as the um, Gaussian distribution. Gaussian distribution, right? And it has got a very complicated density function. So the density function goes as follows: f of x equals again. So there is a fraction in front, so this says 1 divided by sigma square root of 2 pi. Again, you see this particular this particular sigma this particular sigma is the standard deviation, right? So sigma square is the variance, this is the standard deviation, pi is a constant 3.14, and e is E is 2.71828, and so on. So E is a constant raised to the power of negative. It's very complicated. Okay. In the numerator, we have got x minus mu whole square. Again, if you look at mu here, right, this mu is the mean. Okay, the mu is the mean, and in the denominator here you'll find 2 sigma square, right? So this is the formula for the density function, sigma is the standard deviation, right? So this is the formula for our uh, normal distribution, right? It's pretty it's really beautiful formula how it came, but it's quite dangerous and intimidating if you're learning it for the first time. So this fx here is called the density function, density function. And of course, right, this works for all x. X is any real number. Okay, x can be any real number, and here mu is the mean and sigma is the standard deviation. If sigma is the standard deviation, we all recognize that sigma squared is the variance, right? But it looks a little dangerous from this angle. But if you are to look at the graph looks pretty simple. It looks really nice. So since it is nice, let's draw three possibilities, right? Let's draw this as the y-axis or the f of x axis, right? Three different graphs. We'll draw three different graphs. This is the f of x. Okay. So the first graph looks kind of like this. It looks like a bell in temples. You see a bell, right? So it looks like this. It might also look like this, relatively shorter one, or it might look like this, relatively thin, right? Okay, I'll try to make it a little thinner. Okay, so the reason I drew this is as follows. Okay, let's go to the new. Oops, where did it go? Okay, the reason I drew it is because of an important information that I must pass on to you. The second graph has uh, has high variance, and the third graph has low variance. Right, just for your information. Okay. Now, so what happens is we are so what we are doing is that we are trying to again find out. If you look at the top right corner of this particular page here, you'll see that the probability density, top right corner, right? The probability density is in the fx axis, and if we want to find out the value of the random variable, if you want to find out the probability of a range of random variable, we have to draw an area and find out, draw a region, shade the region and find out the area. So similarly here as well, in each of these curves, so if there is a question that is given to you, you have to find the area there, right? But life is a little simpler. Whenever there is a complicated thing like this, we simplify our life by using a particular using simpler using some formula, like using a formula that would be like that can be used to uh, get get the value of the probability in an easier way, right? So what we do is that we will find out something called the z score, right? So we'll find out, so given a probability, so given f of x is equal to 1 by sigma square root of 2 pi e power minus x minus mu whole square divided by 2 sigma square, right, which is very scary. We will find an equivalent simpler expression. Hmm? We'll find out an expression which is pretty simple. So what we do is we will write down we'll write down the following. We'll say that uh, I will use the green here. We'll say that z equals x minus mu by sigma. Okay, so this is the formula that we should have in our mind. What we do is that given the question, from the question we will find out the z. So the z is, so this is called the z score. This is called the z score. Okay, this is called the z score, or it can also be called as the standard score. So given the value of x, we will find out the zx. We'll find out the z, right? So basically, in the question will be asking us as follows. The question will be, if the question says find the probability of capital X being between x1, between a and b, let's say between a and b, right? Again, here, since it is a continuous probability, it does not matter whether we are putting greater than equal, less than equal to, or less than, greater than equal to, or equal to, right? So the solution sketch, the sketch of the solution would be as follows. The solution sketch, the solution sketch will be as follows, right? So from a, we will convert this a to, let's say, z1, and we'll convert this b to z2, right? And then instead of finding, then we'll find this is the first step, right? This is the first step. The second step will be to find the probability of z being between z1 and z2. Okay, so this makes life very simple, because this can be found, the right hand side, right, the final value can be found using use the table. So there is a table on the formula book, right? You will be getting a formula book in your exams, as you are aware of that. I hope you are aware of that, right? From the formula book, we'll find out the formula, we will find out the table, and in the table, we can easily find out what this probability is. So we need not, go through the process of substituting values in this formula and finding out stuff. So what are we doing? We will be substituting the value of x, a, and b in this particular formula here, right? And we'll be finding out z1 and z2. Okay. Now I would want to. So what I'll do is that I will try to get the formula book, a small piece of the formula book here. I'll keep this on the screen, and I'll get the piece of the formula book here. So, okay. So the value of Z is very important. This is called the standard normal distribution, the distribution of the Z. Okay, I have the formula book here. Okay. All right, got it. So I will go to this page and take a small snip of it. Yeah. Okay. So I think on your screen now you can see that there is a table that is given, right? So I have cut off just the top part of the table, right? So this is one of the tables that will be provided to you, and as you can see, right, on the right hand on the top there is a graph drawn, and there is a shaded region, right? The shaded region is the probability that this is basically the probability of z value being between 0 and 1.45. Correct? Now, how do we get this 1.45 and all? So uh, that's what we'll be dealing with it. We're dealing with here. So let's try to solve a problem here, right? Using the table that is given here. Okay, so let's say that okay, you know what? I will try to get some space on top of this to write the question. Okay, okay, I can go further below here. That's it, or yeah, that's enough for me. Okay, so let's try to find out. Uh, let's have a question here, a new question. Mm, I'll use this light green page. Okay, so let's say the question in the question the value of mu will be given. So let x be normally distributed with, in the question it is given, let's say that mu is equal to 5 and sigma is equal to okay, let's say 4, right? Then find the probability that the value of x lies between and 5 and 6. Okay, so this is the question, guys. Let x be a normally distributed let x be normally distributed with mu as equal to 5 and sigma as equal to 4. So we need to find out what is the probability that the value of x lies between 5 and 6. Okay, so this is the question that is given to us. So let's try to solve this question. So the step one, the first step is to find out. So let's write it down, right? We need to find probability of x being between 5 and 6. So let a be equal to 5, b be equal to 6, right? So we'll write down z1. Okay, but before that, we from the question what do we have? We have that mu is equal to 5 and sigma is equal to 4, right? It's given in the question. In the question it is given that mu is equal to 5. Over here in the question it is given that the sigma is equal to 4, right? So we'll use these uh, to find out. We'll use these two values over here, mu and sigma. Both of these are given. Okay, so using these two values we will find out the values of z1 and z2, right? So you saw, right, we had written it here. The plan is, the sketch is here. From a we'll convert z1, from b we'll get z2, and then we'll use the table to find out uh, the particular value of the probability. Now, in order to convert from A to Z1 and B to Z2, we will use this formula. The formula is Z equals X minus mu over sigma, right? So what we'll do is we'll just for the sake of remembering, not X equals, Z equals X minus mu over sigma. This is the formula we are going to use. So let's use this formula. So let's write Z1 equals A minus mu by sigma. What is A? A is 5. What is mu? Mu is 5 divided by sigma is 4. So that is 0 by 4, that is equal to 0. Okay. Z2, we'll find out Z2. Z2 is B minus mu by sigma. What is B? B is 6, right? B is 6. A is 5. B is 6. 6 minus 5 by 4, that is 1 by 4. That would be 0.25, right? So, so what we did is that we just simplified. So we need to find, so we need to find this time probability of, if we scroll up, you will see that we have written z1 is less than equal to z is less than equal to z2. This is the one we have to find out, correct? So let's write in this format. So we need to find z1 is 0, right? Z1 is 0, less than equal to z is less than equal to 0.25. Again, less than equal to are both equivalent. Less than or less than equal to are both equivalent. So doesn't matter. Even if you miss out on this one, it is completely fine. I recommend not to miss out, but still. Okay, so we need to find this. Now let's look at the table. In the table, in the table, what do we see? We see that the probability of the probability of 0 less than equal to z less than equal to 1.45 is given by this area, right? So, but in our case, what do we need to find out? In our case, we need to find out the probability. I'm writing that on the left hand side. We need to find out the probability that 0 is less than equal to z is less than equal to 0.25, correct? So for this table, using this table, we can find that out. What we do essentially is we will try to get this 0.25 written in a specific format. So how will you write the 0.25? So we will write the 0.25 as follows. So we'll write 0.25. We'll just separate this into two parts. So we'll say 0.2 plus 0.05. I hope you are all fine with this notation. We are just separating the decimal places. We are separating the places and we are getting this particular thing. Okay, so what have we got here? Uh, we have got 0.2, in which, immediately after the decimal point there is a value, and we have got another value in which there, after the decimal point, there is a 0 and there is a value, right? So basically, we have got two numbers. Now you look very carefully. The first column over here, in this column, what do we find? In the first column of the table, what do we find? In the first column of the table, we find numbers with just 0 point some number. Okay, I'll just write it in words. This is 0 point some digit, right? And whereas in the y in the first column, right, what do we find? We find 0.0 and then some digit. So our numbers are exactly same as this in this format, correct? So if you look at 0.2, 0.2 is 0 point some digit, and 0.05 is 0.0 and then some digit, correct? So what we do is we find out where our 0.2 is there in the first column. So you can see that 0.2 is sitting right here. I have circled that with the green. And 0.05 is sitting right up on the first row. I am circling that with green. Correct? Okay. So what we do is that we now trace back to that particular value where whose row is 0.2, right? And whose column is 0.5. So we have reached that destination. So we have reached the destination, right? And let's use a green color light green color, yeah. So this 0.0987 is the value that we have got here, correct? 0.0987. So What can we write down here is that we can write down probability of 0 less than equal to z less than equal to 0.25 is equal to 0.0987, and hence our answer over here is going to be uh, so from table p of 0 less than equal to z less than equal to 0.25 is equal to 0.9087. That is the answer. 0.9087. 0987, sorry, not 9087, 0987. My bad. Please excuse me for that. 0987. So this is how we are doing it, right? We are looking at 0.25. We divide that, we kind of separate the digits in such a way, partition the number into zero point 0.2 plus 0.05. So 0.2 is a number which looks like 0 point some digit, right? And the 0.05 looks like some number which is in the form of zero point 0.0 and then some digit, correct? So we look at the row and column corresponding to that particular number, and that is going to give us the probability value, right? So yeah, so that's it on this topic. I think if we can solve a few more problems, I will definitely share with you some homework. You will be able to solve these problems with ease. Okay, so little revision about this topic on normal distribution, which is also called the Gaussian distribution. This is the density function, and as you have seen while solving the problem, we do not need the density function at all, right? Because we are being able to convert this into the value of x into z, which is a standard score or the z score. And then in order to find out some given probability, we will convert the x values to z values, right? So in this entire process over here that you can see on the screen, we are converting. This is a conversion of x values, oops, x values to z values. So what we do is basically we convert the x values into z values, and once this conversion is done, we use the table in the formula book. And as an example, we try to find out, we are given a question saying that x is normally distributed with mu is equal to 5 and sigma is equal to 4. We have to find out what is the value of a given probability. So the x values here, right, a and b are 5 and 6, and using the standard normal formula, right, the standard normal formula as is given on the left hand side, I've just written it down, copied from the previous page, is z is equal to x minus mu by sigma. And once we find out z1 and z2 from a and b respectively, we go back to the table because we need to find, as you can see in the bottom of the screen, 0 less than equal to z less than equal to 0.25. And in order to find that, we kind of separate the 0.25 into 0.2 plus 0.05, and we look at the row corresponding to 0.2, right? It's because it is 0 point some digit format, and we look at the column 0.05 because it is in the format 0.0 and then some digit, and then they meet at a particular box. It will definitely always meet at a particular box, and in that box we can see that we have written we have got the number 0.0987, and that's exactly the probability that we wanted, right? Okay, okay, so yeah, so that's it for, I think, today we will wrap it up here, and we'll solve some problems later whenever we are available the next time.